name is Samuel, and today I will be presenting on adders and multiplexers. These two components may seem small in design, but they are the foundation in digital electronics and form a critical part of computer architecture. Introduction to digital electronics. Introduction to digital circuits. Digital circuits use binary signals, zeros and ones. They are the building blocks of the CPU and memory units. Before we dive into adders and multiplexers, it is important to understand where they fit. Digital circuits operate using binary values, zeros and ones, and are found in all computing devices. Adders help us to perform binary arithmetic operations, and multiplexers allow us to select from multiple inputs. Both are essential in how CPUs process data and make decisions. Some may ask, what's an adder? An adder is a logic circuit that performs binary addition. It accepts binary inputs, usually 2 bits, and outputs a sum and carry value. Adders are vital components in arithmetic logic units, or ALU short form, which is part of the processor that performs calculations. Every time a computer adds numbers or processes binary operations, adders are working in the background. They are mostly used in arithmetic units of processors. Half adders. A half adder is the most basic form of an adder. It has two inputs, let's say A and B, and gives two outputs, sum and carry. The sum is obtained using an XOR bracket exclusive OR gate, and the carry comes from an AND gate, as seen in the truth table. When both inputs are 1, the sum becomes 0 and the carry becomes 1. But note that it cannot accept a carry from a previous addition, which makes it limited in real operations. A full adder. A full adder overcomes the limitations of a half adder by adding a third input, carry in. This allows it to be used in multi-bit addition, where carries from previous stages must be accounted for. A full adder is typically made from two half adders and an OR gate to combine the carries. The sum is obtained by an XORing all three inputs. The carry out is generated using a combination of AND and OR logic. It is the standard unit for binary addition in processors, as you can see. Types of adders. When we need to add binary numbers with more than 1 bit, we connect multiple full adders together. This setup is called a ripple carry adder because the carry output of one full adder becomes the carry input of the next, like a ripple effect. Although it's easy to design, it has a downside. The operation becomes slower as the number of bits increases. That's where carry look-ahead adders come in. They speed up addition by predicting carry values ahead of time, reducing the delay. What is a multiplexer? A multiplexer, or MUX, is a device that selects one input from multiple sources and forwards it to the output. It uses select lines to determine which input to choose. Think of it like a TV remote. You select one channel from many options. Multiplexers help reduce circuitry complexity and are used for data routing and signal control. Multiplexers, also called the data selectors. Then we have 2 by 1 and 4 by 1 multiplexers. A 2 by 1 MUX has two inputs and one select line. If the select input is 0, it chooses the first input. If it's 1, chooses the second. A 4 by 1 MUX works similarly but has 4 inputs and 2 select lines. The combination of the two select lines determines which input gets sent to the output. This is fundamental in decision making processes in circuits and are often built using basic logic gates. Uses of adders and multiplexers. Adders are used in many digital systems to perform binary additions, subtractions, and incrementing. In calculators, timers, counters, and the CPU's arithmetic unit. Multiplexers, on the other hand, are used to select data from memory, to switch between signals or instructions. Both components help minimize hardware usage and improve circuit efficiency. Real life applications. Others are inside almost every device, from your mobile phone to larger servers, handling all forms of calculations. They are critical in alus of memory processors and embedded systems. Multiplexers are used in real-world systems like signal routers, where data from different sources is combined. Memory address decoders to choose which memory blocks to access, and even in communication systems like digital radios and TV broadcasting. Some are even embedded systems. Example, watches and appliances. Summary. In summary, adders perform arithmetic by adding binary numbers. Multiplexers act as selectors to choose one out of many data lines. They are both essential in building CPUs and digital circuits, and the operation is based entirely on basic logic gates. Although they may seem simple individually, together they make high-speed computing possible. Thank you for listening. Questions are welcome. Thank you very much for your attention. I hope this presentation has helped you understand the importance and functions of adders and multiplexers in computer architecture. I'm happy to take any questions or clarify anything you'd like to know more about. Thank you.